Okay, hi everyone, welcome to this live stream day. Today, I want to continue my discussion of Windows Server 2000. So I'll just share my screen here. Okay, Windows 10 security and access control in Windows 2000, protecting systems and data with advanced security measures. Security is a cornerstone of any server environment, and in Windows 2000 and Windows 2000 Server provides a robust set of tools and features to help administrators secure resources, users, and data, from user authentication and access control to auditing and encryption. Windows 2000 incorporates multiple layers of security to protect against unauthorized access, data breaches, and other security threats. In this chapter, we'll dive deep into the key security and access control features in Windows 2000 Server, including managing user accounts, control access to resources, auditing activities, and ensuring system integrity. So 10.1 authentication and user accounts. Authentication is the process of verifying the identity of a user or system attempting to access resources. Windows 2000 introduces Active Directory AD, which allows for centralized management of user accounts, security policy, and access rights across an entire domain. Understanding how to configure and manage authentication is essential for maintaining a secure environment. User accounts. User accounts in Windows 2000 are stored in Active Directory and are used to authenticate users and grant them access to network resources. Each user has a unique identifier, SID, and associated group membership that defines their permissions. Domain user account groups created in Active Directory and are valid across the domain. Local user accounts created on individual machines for local authentication. Global and local groups used to organize users with similar access needs. Security groups are key to managing permissions across the domain. Authentication methods. Kerberos authentication, the default authentication protocol in Windows 2000, providing secure mutual authentication between the client and server. NTLM authentication, used when Kerberos is unavailable. It is less secure and should be avoided if possible. Smart cards provide two-factor authentication for highly sensitive environments. Best practice: always use strong, unique passwords and enable account lockout policies to protect against brute force attacks. Access control is fundamental to managing who can access data and what actions they can perform. Windows 2000 provides NTFS, New Technology File System, and share permissions as primary methods for controlling access to files and folders. NTFS permissions. NTFS allows for detailed access on files and folders. Permissions can be set for both individual users and groups, and they are more granular than share permissions. Key NTFS permissions include permission description, full control. Always allow users to perform any operation on the file or folder. Modify, allow users to read, write, and delete files. Read, execute, allow users to view files and run executable files. Read, allow users to view files and folder contents. Write, allow users to create new files and folders. Share permissions. Share permissions are applied when users access files over a network share. There are three basic levels of share permissions. Read allows users to view files and folders. Change allows users to view, modify, and delete files. Full control allows users to perform any action on the files or folders. Important note: the most restrictive permission between NTFS and share permissions will apply. For example, if you If a share is set to full control but NTFS permissions is read only, the user will only have read-only access. 10.3 Group policy is a powerful tool for enforcing security settings across all systems in a domain. By using group policy objects, GPOs, administrators can configure security settings, user rights, and account policies centrally. Key security settings in group policy: password policies, set requirements for password complexity, length, and expiration. Account lockout policies: enforce account lockouts after a set number of failed logon attempts. Audit policies: configure auditing to track and log security related events such as logon attempts or file access. Secure filtering: use group policy security filtering to ensure that only specific users or groups are affected by a particular policy, and enhancing security by limiting exposure. 10.4 Auditing and monitoring activities. Auditing is crucial for maintaining a secure environment as it enables administrators to track user activities and detect potential security threats. Windows 2000 includes built-in auditing features that allow you to monitor and log events related to file access, user logins, and system changes. Enable auditing. 1. Open local security policy or group policy management. 2. Under advanced audit policy configuration, configure the types of events you want to audit, such as audit account logon events, object access, log off events, policy change events. 3. Set auditing at the file system level by configuring advanced security settings on files and folders. Event logs: the event viewer displays security related events generated by audit policies. Administrators can filter logs to track specific activities such as failed logon attempts, file deletions or modification accounts, changes to user accounts. Tips: regularly review event logons to identify suspicious activity such as unauthorized access or privilege escalation. 10.5 Encryption and data protection. Windows 2000 supports several methods for securing data, including file encryption and secure communication protocols. Encryption is essential for protecting sensitive information from unauthorized access, both at rest and in transit. Encrypting file system: EFS. EFS allows users to encrypt files and folders on NTFS volumes. Once encrypted, only the user who encrypted the file or authorized users can decrypt and access the file. To encrypt a file, right-click on a file or folder, select Properties, then choose Advanced and check the box for Encrypt Contents to secure data. Backup EFS keys. It is important to back up the encryption keys to avoid data loss in case the user account is deleted or compressed. Secure sockets layer: SSL and VPN for secure communications. Windows 2000 supports SSL for encrypting data transmitted over the network. Additionally, VPN, virtual private network support, allows for secure communication between remote users and internal resources. 10.6 User rights assignment and privileges. User rights assignment is a critical security feature in Windows 2000 that allows administrators to assign specific rights and privileges to users or groups, such as the ability to log on locally, backup files, or shut down the system. Common user rights: log on locally, permit a user to log onto a computer locally physically at the machine, backup files and directories, allows a user to bypass file permissions and backup files, shut down the system, grants a user permission to shut down the system. Best practices: minimize administrative rights. Users should only have the rights they absolutely need to perform their jobs, assign rights using groups, rather than assigning rights to individual users, groups, to manage permissions efficiently. Restrict sensitive actions, only grant rights like backup or shut down to trusted administrators. 10.7 Network security. Network security is another essential component of securing a Windows 2000 server environment. Windows 2000 offers multiple features to protect network traffic, including firewalls, IPsec, and routing and remote access (RRAS) firewall. The Windows firewall introduced in later versions is not available in Windows 2000, but administrators can use third-party firewall solutions to protect servers from unauthorized network access. IPsec, Internet Protocol Security. Windows 2000 supports IPsec, which enables encryption and authentication of IP traffic. IPsec can be configured to ensure that only authorized users and machines can communicate over the network, filtering IP traffic. Use IPsec to define rules for incoming and outgoing traffic based on source, destination, and protocol. VPN and RRAS. For remote access, Windows 2000 supports Remote Access Service (RAS), which can be configured to allow users to securely connect to the corporate network over the internet. VPNs, virtual private networks, provide encrypted communication channels, ensuring that data remains secure while in transit. 10.8 Security best practices for Windows 2000. To maintain a secure and reliable Windows 2000 server environment, follow these best practices. Enforce strong password policies, length, complexity, and expiration. Regularly update software to patch security vulnerabilities. Use encryption, EFS, and SSL to protect sensitive data. Enable auditing to track security-related events and changes. Minimize user privileges by following the principle of least privilege. Limit remote access by configuring VPNs and firewalls. Backup encryption keys for a recovery process. Summary. Security and access control are vital to maintaining the integrity of your Windows 2000 server environment by leveraging authentication, NTFS, and share permission, group policy, encryption, and auditing. Administrators can secure both user data and system resources. Regular monitoring and adherence to best practices will help mitigate security risks and ensure a robust defense against threats. In the next chapter, we'll explore backup and recovery techniques to ensure your systems and data are protected in case of disaster. So, chapter 11, backup and recovery strategies. In any enterprise IT environment, data protection is paramount, whether for disaster recovery, system migration, or day-to-day backup operations. Having a reliable and efficient backup strategy is essential. Windows 2000 Server provides a variety of tools to perform backups, as well as options for recovery in case of a system failure or data loss. This chapter will walk you through the backup and recovery tools available in Windows 2000, best practices for creating and maintaining backups, and how to develop a disaster recovery plan to minimize downtime and data loss. 1.11 Introduce a backup and recovery in Windows 2000. The purpose of backup and recovery in Windows 2000 Server is to protect critical data and ensure that systems can be restored to a functional state after data loss, hardware failure, or malicious attack. Windows 2000 includes several built-in tools such as backup utility and NT-backup to assist in these processes. A good backup strategy involves identifying critical data, what needs to be backed up and why, choose a backup method, which backup type is best for your environment, planning and recovery, how will you recover lost or damaged data? Backup is not just about data, it also includes system configurations, settings, and the operating system itself, ensuring that you can restore services quickly after a failure. 11.2 Types of backups. Windows 2000 offers several types of backups, each with its specific use case and benefits. Understanding the different types of backups is essential for creating an efficient backup strategy. 1. Full backup. A full backup copies all selected files and directories, regardless of whether they have changed. This is the most comprehensive backup type, but it requires the most storage space and time to complete. Pros: fastest recovery, only one backup to restore consumes more storage space and time for backup. 2. Incremental backups. An incremental backup only copies files that have changed since the last backup, either full or incremental. This type of backup saves time and storage as it only includes changes made since the last backup. Pros: saves time and storage space. Cons: restoration can take longer as all incremental backups must be restored sequentially. 3. Differential backup. A differential backup copies all files that have changed since the last full backup. Unlike incremental backups, differential backups do not reset after each backup, meaning each differential backup will continue to grow as more changes are made. Pros: faster recovery than incremental backups. Cons: requires more storage space than incremental backups but less than full backups. 4. Copy backup. A copy backup is similar to a full backup, but it does not affect the archive bit, meaning that it doesn't reset the file's status for subsequent backups. This type of backup can be useful for duplicating files without altering the backup file. Pros: useful for copying specific files. Cons: can increase the complexity of backup management. 11.3 Configuring backup with NT Backup. NT Backup is the built-in tool in Windows 2000 for performing system backups. It provides a graphical interface for scheduling and managing backup operations, and it supports various types of backups, including full, incremental, and differential. How to configure a backup using NT Backup. 1. Open NT Backup. Click Start, go to Programs, then Accessories, choose System Tools, select Backup to open the NT Backup utility. 2. Choose Backup Type. In the Backup Wizard, choose the type of backup you want to perform: full, incremental, differential. Select Files to Backup. Choose specific files, folders, or system components to backup. You can backup files on local drives, network shares, and system state data. 4. Select destination. Choose the destination for your backup, e.g., tape drive, external hard disk, or network location. 5. Schedule backups. You can schedule backups to occur automatically at specific times, ensuring regular and consistent data protection. 6. Run the backup. Once configured, start the backup process. NT Backup will create a backup of the selected data and store it at the specified destination. Important NT Backup options. Backup system state includes critical system components like the Windows registry, boot files, and Active Directory if applicable. Verify backup. After backup, you can choose to verify the integrity of the backup to ensure it has been completed successfully. Restore Wizard, a companion tool that helps you restore files from backups by selecting the backup set and restoring files to their original locations or alternate locations. 11.4 Using the backup utility for system state and critical data. One of the most important aspects of a backup strategy is ensuring that the system state is backed up regularly. This includes essential components like registry, stores configuration settings for Windows 2000 and installed applications, boot files, essential files required to start Windows Active Directory if applicable, the database that stores information about users, computers, and other resources in the domain, COM plus class registration database, a critical part of system configuration, backing up the system state. To back up the system state in NT Backup, 1. Select system state from the available backup options. 2. This backup will include key configuration settings necessary for full system recovery. Important: if you're running a domain controller, backing up the Active Directory is critical for disaster recovery as it contains all user account information and security settings. 11.5 Disaster Recovery Planning. A disaster recovery plan is essential for minimizing downtime and data loss in case of a catastrophic failure. Planning ahead allows your organization to recover quickly and effectively from failures, ensuring business continuity. Key elements of a disaster recovery plan. 1. Risk assessment. Identify potential risks to your system: hardware failure, power outages, fire. 2. Backup strategy. To develop a backup schedule and retention policy that includes full, incremental, and differential backups, as well as off-site storage of critical data. 3. Recovery time objective, RTO. Define how long it should take to restore a system after a failure. Recovery point objective, PRO. Define the maximum acceptable amount of data loss or how recent the data should be at the time of recovery. Off-site backups. Store critical backups off-site, either through physical storage tapes or external drives or through a cloud service to protect against localized disasters like fire or theft. 1.11.16 Testing and verifying backups. It is not enough to create backups and hope they will work when needed. Testing and verification are critical parts of any backup strategy. Testing backups. Regularly test restores. Schedule regular test restores of critical systems to ensure that the backup data is valid and can be restored in a timely manner. Verify the integrity of backups. Use tools like NT Backup's Verify Backup option to confirm that the backup has been completed without errors. Test disaster recovery plans. Simulate disaster recovery scenarios to test how quickly your team can recover from system failures. Tip: perform a full restore test at least once a year to validate your recovery procedures. 11.7 Automating backup operations to ensure that backups are completed regularly and reliably. Windows 2000 provides tools for automating the backup process using scheduled tasks for automation. You can schedule backups to run at regular intervals using scheduled tasks in Windows 2000. In NT Backup, select scheduled job to automate backups on a daily, weekly, or monthly basis. You can configure the backup to run during off hours to reduce the impact on system performance. Tip: schedule backups to run during non-peak hours to avoid performance issues. 11.8 Restoring data from backups. Restoring data from backups is an essential skill in the event of system failure. In Windows 2000, the NT Backup Restore Wizard helps administrators restore individual files, system states, or entire volumes. Steps to restore data. 1. Open NT Backup and select Restore Wizard. 2. Choose the backup set you wish to restore from. 3. Select the files and folders or system components you want to restore. 4. Choose whether to restore to the original location or a new location, useful for testing or avoiding overwrite. Start the restoration process. Important. If restoring the system state, be careful not to overwrite active system files. Always ensure that the backup version is suitable for the recovery scenario. 11.9 Best practices for backup and recovery. Backup regularly. Schedule backups daily for critical data and weekly for less important data. Test backups regularly. Test the restore process to ensure you can recover when needed. Keep offsite backups. Store backups offsite or in a cloud service to protect against local disasters. Use multiple backup media. Use a combination of media, e.g. tape drives, external drives, cloud to protect against hardware failure. 5. Document your procedures. Document backup schedules, recovery procedures, and disaster recovery plans. Summary. Backup and recovery are critical aspects for managing any Windows 2000 server environment. By understanding the different types of backup, configuring backup utilities, and developing a disaster recovery plan, administrators can ensure that data is protected and that systems can be quickly restored in the event of a failure. Regular testing and automation of backups will further enhance reliability and reduce the risk of data loss. So in the next chapter, I'll go into performance and monitoring tuning. So I hope you enjoyed this video. I'm going to leave it here for today. So thanks for watching and have a good week.